So in finding out whether or not we hit the rabbit, we basically want to know how far the Porsche has gone. Now we have 2-second time intervals, and we have a maximum speed and a minimum speed on each time interval because we're assuming we're hitting the brakes and that the speed is decreasing the whole time. Now remember one thing, distance equals rate times time. So for these first 2 seconds, what we might want to look at is what is the fastest or furthest we possibly could have gone. Well, the fastest we were going during the first 2 seconds is 100 feet per second, and if we did that for 2 seconds, we would travel 200 feet. So the most we could go in the first 2 seconds is 200 feet. What we can do is the same thing for the next 2 seconds. The fastest we're traveling, 64 feet per second for 2 seconds. The furthest we can go in the next 2 seconds is 128 feet. Alright, we're going to do that for each 2-second time interval. And so during the 10-second period, the furthest we possibly could have traveled is 440 feet. So what we've done is use the fastest speed on each time interval to estimate how far we possibly could have gone in each 2-second interval. So we have an upper bound of how far we've gone once we've applied the brakes. We can do the same thing to get a lower bound, except what we'll do is on each 2-second time interval, we'll use the lower speed. So we went at least 128 feet in the first 2 seconds because we were going at least 64 feet per second for those 2 seconds. Remember, these are very conservative. You know, we started at 100 feet per second, went down to 64 feet per second, but we can only work with the numbers that we see. In the second 2 seconds, between 2 and 4 seconds, the slowest speed we were going was 36 feet per second. If we did that for 2 seconds, we would have traveled 72 feet. So what we can do is do that for all of the lower bounds, and you can see that we get that our minimum distance traveled is 240 feet. So we know that our total distance traveled is somewhere between 240 feet and 440 feet. Okay? We have a lower estimate and we have an upper estimate. Problem is, the difference between those estimates is 200 feet. So we need to think about how we can get a better estimate. So how can we get a more accurate estimate? Well, what if we knew the speed every second? So if we had the time intervals down to every 1 second, and we had those speeds, we're now going to get a little bit better approximation, because what we're going to do is find out how far we've traveled on every 1 second time interval. We'll still use the highest speed for the upper estimate, and then we'll use the lower speed for the lower estimate. So here would be our upper estimate. Notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 calculations. It starts by using the highest speed, the 100, and we don't use the last speed, the 0. And so we get an upper estimate of 385 feet. Our lower estimate doesn't use the very first speed, but uses the other 10, including 0. So what we got now is the total distance traveled is between 285 feet and 385 feet. Only 100 feet apart. A much better estimate. So the more time intervals we had, the better our estimate was.